I'm going to go ahead and now introduce our first speaker here on the next slide. And our first speaker is Pavel. And I promised myself that I would not mangle his name, but I'm not even going to try. Pavel is actually based in Poland, and he is staying up late, right, to be here with all of us. He's a senior security consultant at Securing, and it's 1:30 in the morning for him. So everybody, let's give him a warm virtual welcome. And Pavel, I'm going to hand it over to you. Thank you so much.
Thank you very much, Frank, for introduction, and to welcome everybody. And thank you for joining my session. So my name is Paweł Rzepa, and I work as a senior security consultant in Polish company called Securing. On a daily basis, I'm doing penetration testing as well as cloud security assessment. Some of my article you can find on my Medium blog, and from time to time, I'm sharing interesting news from cloud security world. So if you're interested, I encourage you to follow me on my Twitter and LinkedIn accounts. So what are you gonna hear on my today's session? First of all, we will briefly go through the cyber kill chain, what it is, and what steps are we going to follow. Then I will do a little introduction to understand the attack, and finally I will walk you through step by step by the attack, and based on the attack we will define some countermeasures that you can apply in your AWS account not to become another victim. Okay, so cyber kill chain is basically a structure of the cyber attack. And using the Cloud Mitre attack framework, there can be defined 10 phases of such attack. So it starts from the initial access, like exploiting public-facing applications, and then we will go through the enumeration of cloud services to finally find another weak point that allows for the escalating privileges. And as an administrator, I will show you how to impair defenses, and finally how to create how an attacker can create a backdoor in the target account. So imagine there's the company called Domain Analytics. They are pretty new to AWS, and they are using the Elastic Compute Cloud Service, which is usually referred to simply EC2. In other words, EC2 is the virtual machine in the cloud. However, Amazon preferred to call it EC2 Instance rather than virtual machines in the cloud. So on this EC2 instance, there is running a web application, and also on the same EC2 instance, there is also running Jenkins. And Jenkins is responsible for creating the new packages of the web application. So once the new code is, new version of the web application is released, the Jenkins is building it on the new EC2 instance and spin up the new EC2 instance with the latest version of the web application. However, to be authorized to spin up the new EC2 instance, Jenkins has to be somehow authorized, and it can be done by the instance profile. So you are attaching a role to the EC2 instance with the permissions to spin up the new EC2 instance. The role is actually the abstract concept, which is defined by the AWS access keys. And the role is stored, as you can see, the role is stored in this metadata. Now, Metadata Service is the special service where you can find the information about your instance, like the ID of your instance, like internal IP addresses, things like that. And this is the special link local address, which is accessible only from your instance. In other words, it works only in one network segment. So it's not rootable. And from the security point of view, it is pretty interesting place, because if there is a role attached to this EC2 instance, then you can find the AWS access keys of this role in the metadata service. Some of the vulnerabilities, like unintended proxy, external XML entity, or the server-side request forgery, they are all much more dangerous than usual in the cloud, because using those vulnerabilities, it is possible to access the metadata and, as a consequence, access the instance profile, so the role attached to this EC2 instance. And what attacker can do with such exfiltrated keys? Well, for example, in the Capital One breach, the exfiltrated keys allow for accessing the S3 storage and to compromise millions of data, millions of customers' data. In the Tesla example, the attackers were able to set up a crypto mining software. Please remember that in the cloud world, the compute power is a resource which can be easily monetized. So a lot of attackers will look for spinning up the new EC2 instance or their cryptojacking software. In the worst case scenario, when the attacker becomes an administrator, it is possible to remove all the resources. And as it was in the CodeSpaces company example, the attacker removed all the resources. You may not hear about this company, because this company stopped existing just after the attack, because all of their resources, including backups, were under one AWS account. All right, I hope now it's clear for you and we are ready to go through the attack. So every attack begins from reconnaissance. The internet, as you probably know, is full of bad guys. One of them was using the Shodan.io. And using this tool, Shodan.io, you can specify a simple query like this. You can see here. So in other words, it says, give me all the Amazon IP addresses that have the port 80 open. And as you can see, the Shodan reflects back almost 100,000 results. One of the results was the domainanalytics.org application. So the attacker finding it that, well, this is a pretty simple web application where you can specify the domain name. For example, if you type there the Polish government web page, then you can see that actually this domain expired in 2017. So maybe that was the reason why in 2019 it was took over, and instead of content from the government, there were presented some porn. Furthermore, based just on the IP address, it is possible to map the IP address to the service, and also you can know based on the IP address under what region this service is running. So, time for the attack. The attacker, instead of putting the domain name, specify the metadata address. So the special address 169.254.169.254, and voila, the web application seems to be vulnerable to server-side request forgery. So now the attacker can query another endpoints of the metadata service to finally get to the security credentials of the role that is assigned to this EC2 role. It is called EC2 role. This is the custom name. And bingo, we have the access key ID, the secret access key, and the session token. In other words, now we are able to assume this role that is attached to this EC2 instance. From the attacker perspective, it is just a beginning. So you can do all the discovery steps manually. However, there's the open source AWS exploitation framework called Paku. And if you are familiar with the Metasploit framework, Paku is something similar, however, related with the AWS. So there are the enumeration procedures or the exploit techniques. They are all automated in this Paku. So once you exfiltrated the keys, it's time to set up the keys in the Paku. So all those attack and enumeration steps will be going out as from the Paku as the EC2 role. Okay, there is also a need to set up the region. As you remember, based on the IP address, it was possible to deduce that it is the EC2 instance running in EU West 1 region. There are a lot of modules in Paku. For example, one of them is EC2 Anom and other exploitation modules, which we're going to cover in a moment. So the first task the attacker would like to do is to determine what permissions are gained. In Paku, you can run, for example, the IAM brute force permissions module, and it gives the attacker an information that actually the role assigned to this EC2 instance has the EC2 wildcard actions, which is unfortunately pretty common what I can see by doing my cloud security assessments. Then, so time for enumerating the EC2 service. What can we do in Paku running the module EC2 Anom? And then to display the content, you can specify the command data and then the name of the service. And the output, of course, was very, very big. However, the most important information from the attacker's perspective was that there's the one stocked instance, however, with the instance profile called admin attached. So this information is pretty juicy for the attacker. The problem is how, having only the EC2 permissions, how to access this stopped EC2 instance. And it is possible using the user data. User data is the concept where you can specify the instructions that will be executed during the initial boot process. So for example, imagine that you are spinning up the new EC2 instance and then you want to update all the dependencies or to pull the latest version of the code. All of these instructions you can specify in the user data. The problem is that it will be run just once during the initial boot process. However, there's a trick to add the directive cloud boot hook at the beginning, and then the user data will be executed every single time the instance is restarted. So here I'm specifying the bash one-liner with my attacker's external IP address and the port on which the attackers is listening. So to visualize you this attack, having the EC2 role, it is possible to modify attribute of user data and then to start the EC2 instance. Once the EC2, this new EC2 instance is started, the user data will be executed. So the attackers will is able to catch reverse shell, and finally, using the same technique of accessing the metadata, it is possible to access the admin profile. So in other words, get the administrator permissions. And by the way, this chain was found in the real case during my commercial cloud security assessment. Okay, how does it look like? How the attack look like in practice? So there's a module in Paku called EC2 Startup Shell Script. So let's print out the help of it. And using the script parameter, you can specify the new user data that you want to replace in the target EC2 instance. So in the other terminal, I'm verifying my external IP address. And then I have in the file called refshell.sh, I have this bash one-liner, which is the reverse shell I want to put on this target EC2 instance. I'm listening on the lead port, the 1337 port, for upcoming reverse shell. Then in other terminal in Paku, I'm starting the EC2 startup shell script, and as you can see, in the output, the machine was it is always restarted, so it is always like stopped, even if it is already stopped. But it is not a problem. Only when the machine is stopped, you can replace the user data. You can modify this attribute, and then the machine was started. So once the machine will be up, I should receive the reverse shell. So just give it a moment, and voila. We have the reverse shell to this stopped instance, and now doing the same trick by curling the metadata of this new EC2 instance, you can see that there we have now the access to the instance profile called admin, and the attacker became the administrator. So the next steps would be to disrupt monitoring services, like turn off the AWS guard duty, or turn off CloudTrail, or set CloudTrail to monitor just one region. And finally, the attacker would like to have the persistent access to have the backdoor, and there are numerous ways how to do it. One of it is to creating additional access keeper for every existing user. So you have to know that in AWS every user can have 2 access keepers. And of course, there's no notification from the user's perspective that somebody created another access keeper for your account. Okay, so time for countermeasures. What can you do to protect against such attacks? First of all, enable Instance Metadata Service version 2. This is the new option announced in the previous year. And it protects you from the attacks like misconfigured proxy or server-side request forgery. I don't want to go into the details of this, but you have to explicitly enable it to be active. So by default, all the EC2 instances are running with the Instance Metadata Service in version 1. Next, you can detect all known misconfigurations using tool Prowler. I really like this tool, and I saw that the author of this tool will have later today the presentation, so please don't miss it. This is a great tool that will give you information about all misconfigurations like publicly exposed services or publicly exposed resources, things like that. Furthermore, you can use a tool called Cloudplaining, which I also really like because it provides you with the potential privilege escalation paths. Like for example, that using this role, you can then access the EC2 instance profile with much higher role. You can also, and you should, use the AWS Organization to separate the accounts. So for example, using the AWS Organization, you can separate the developer account and the auditor account, where the logs and any actions related with logs, like turning off the logs or removing the logs, will be only allowed from the auditor account, and it will not be possible done from the developer account, even if the user of the developer account becomes an administrator. And this is done by the service control policies that are offered from the AWS organization. And finally, remember about setting up the security monitoring. Even if you have, even if it is, if you don't have misconfigurations, you never know if the credentials of one of your user get compromised. So using the security monitoring services like the guard duty or the AWS config, you can find that something bad is happening in your AWS account. And there are so many monitoring services that actually Amazon announced another service called Security Hub, where you can aggregate all those informations and have this information in just one place. Okay, so key takeaways. Please remember to regularly audit your cloud infrastructure, detect misconfigurations, and detect any design flaws, like for example, having the web application and Jenkins on one EC2 instance. Harden it, and remember that it is a process. It is not just a one-time task. It should be done periodically. That's all from my side. I hope you enjoy it, and I hope you learned something new. If you have any questions, I would love to answer them.